All right. Good evening, everybody. Good evening once again. So, in the last class, we completed MEFA, and wait, my opinion for this class is to complete some mathematics, right? Some P and S proofs. Okay, I need to organize my desktop. It is very messy. Hey, good evening. So, I wanted to share some thoughts with you. I have been studying mathematics recently, even though I do not have any much of trouble solving the problems as per the academic standards are concerned. But I feel like I lack the real mathematical spirit, like what differentiates a person who just does math and a person who is a real mathematician. The proofs, right? He is able to understand the behind the scenes of the formula, and I seem like I am lacking that. So I need to know some proofs for some formulas, especially formulas of correlation and regression. Wait, I'm going to list the formulas for you. So I need the Carl Pearson's coefficient of correlation. There are actually three formulas for that: normal coefficient of correlation and step deviation method, and we also have Spearman's rank correlation coefficient, and also Spearman's rank correlation coefficient when equal ranks are given. So I need to have the proofs for those formulas. Yep, let's see how this thing responds. Okay, the what do you say? This one kind of stuff. Hello, is the cam visible? Yeah, the cam is working right now. Yep. All right, let's see. Covariance. Wow, this thing right here is just gold over here. It's the curiosity. This is going to be the real difference between a person who just knows mathematics and a person who actually does mathematics. So let's try to become that person that actually does mathematics. The standard formula for Carl-Peterson's coefficient of correlation R is equals to covariance of x comma y by so this can be done as sigma x minus x bar y minus y bar by x minus x bar whole square y minus y bar whole square under root. So this is the normal standard deviation. How strongly vary together. COV stands for covariance. How strongly do they vary? Vary together, yes. Together is a term that needed to be, that cannot be omitted. Yep. That is called covariance. X comma y is 1 by n. X minus x bar y minus y bar. Covariance is unit dependent. Okay. We need a pure unit free number between -1 and 1. Yes, that makes sense as well. Right, and we divide covariances by their standard deviations, which makes them dimensionless. So covariance by standard deviation. That gives you the correlation. That is basically the Pearson's formula. Nice. This formula is actually the cosine of angle. Is actually cos theta. Things seem to connect, right? Yes, they seem to. Step deviation method x minus step deviation is just coded variables. Yes, he is now talking like a CS major. U is equals to x minus a by h and v is equals to y minus b by h. Assumed means okay, h and k are scaling factors. Okay, alright. Yes, you need to use k because there is no necessity that this scaling factor and this scaling factor is going to be the same. Correlation does not change under linear transformation. It is allowed because correlation does not change under linear transformations. Okay, after substitution and simplification, this is just algebra from expanding. Let's see. Let's actually try to substitute. X minus a by h. So instead of x bar, you are right. How are you substituting? Oh wait, is it Spearman? No, Carl Pearson. Yes. You don't want the formula. You want to see where the substitution actually happens. Yes, this is a real Carl Pearson's formula. Okay, rearranging. All right. All right. All right. All right. All right. Alright, 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 alright. So, yeah, still I think I need to go through this. Oh my god. Then we got 3 of Spearman's rank correlation coefficient. So we will start from here. Sigma x minus x bar sigma. Wait. It is covariance. Do we have any mathematicians? All right. This is real Pearson's formula, and now u is xi minus a by h, v is y minus b by k. So from this, x are a plus uh, v y is equals to b plus vk. Okay. Now we are substituting rewrite x minus x bar x is equals to a plus h u. Okay, the next bar will be a plus h u bar y. Just average a and h are same. If you need, you can just do this if you want, or maybe let's better write it out. Sigma x by n, sigma a plus hu bar by n, a plus hu bar, right? Sigma a by a is just a. Sigma a by n is equals to a, and sigma h by n is h2. That makes sense. Now we are subtracting and you will get this. Now x minus x bar will be what? A plus hu minus a plus hu bar. So a plus hu minus a minus hu bar, a gets cancelled out. H into u minus u bar. Similarly, y minus y bar is equals to k into v minus v bar. Substitute into the numerator. Take constants outside, substitute into the denominator. Correlation does not change under linear transformation. Okay. All right. So I have understood that, yeah, right? I mean, substituting x and y with u and v is the same because, as you said, the Carl Pearson's coefficient does not change with linear transformations. But now the problem arised is, how did you come up with sigma u minus u bar into v minus v bar is equal to sigma u v minus n u bar v bar? How did you come up with that conclusion? If that was clear, the computational formula will be clear all by itself. Yeah, we do not know summation in the first place. Okay, okay, okay. Handle each term carefully. U bar, yes, that is a mean, that is a constant, they do not depend on I. That's true, that is crucial, okay. Leave it as it is, okay, okay, okay. Replace summations using mean definitions. Okay, okay, okay. Wow. Covariance of x and y. What is E? I lack a lot of knowledge in probability. I mean, in statistics. What is that? Correlational covariance. Covariance and coefficient. Nope, not that one. Correlation does not change under linear transformations, yes. So he said this as some sort of identity. U minus U bar, V minus V bar, UV minus N U bar V bar. An identity. This result is very important and we got a problem with typing in the chat. So the way I think is like people come and watch the stream for like 2 seconds and go away, and by the time they come back, they might check the message. So if you don't want me to type, then it's fine, bro. P understands for probability and statistics in our lingo. All right. So we need to prove this one now, it seems. U minus U bar V minus V bar. We are just using normal distributive identity UV minus UV bar minus U bar V plus U bar V bar because minus times minus is plus. Apply sigma U bar V bar are constants. Okay. So it can be written as V bar sigma U minus U bar sigma V plus N V bar. Basic summation rules. Adds n times. Yeah, everything is n times. If that were to be said. Replace summation using mean differences. Okay. We know U bar is sigma U by n. So sigma U is U bar n. I will use this conclusion. So that is U bar n V bar n minus V bar U bar n minus U bar V bar n. Alright, and that's n U bar V bar. So what did we get now? These are the same terms. Yes, they get cancelled out. Mhm. Wait, can't you write sigma UV? Okay. This is wrong. This is wrong. Why is this wrong? Because sigma UV is not same as sigma U sigma V. Let's write that as a note point. Sigma UV is not equals to sigma U sigma V. I mean that might be very basic, but it is a silly mistake. And now we came with our conclusion. So concluded. Or you might write the classic hence proved as well. Fundamental identity of statistics. Now that I'm curious, you mentioned it as a fundamental identity in statistics. I think COV stands for covariance, and what does E stand for? And also, I just noticed that summation of UV is not equal to summation of U times summation of V. Like I kind of misdid that. Expectation, yeah, I thought of it. If you flip a fair coin, okay. For discrete data, expectation. Please, okay. Expectation is just the mean. So when you're out. E is just more general notation for average, okay. Expectance. Covariance measures how much does the average of product differs from the product of averages. Okay, it really makes sense. Some note. Let's do note 2 as well. E of x is equals to expectance, and for discrete data it's same as average. Okay, that completely makes sense. So now this, where are we? No, literally, where are we now? Wait, what? Dude, where is the formula? Oh god. This one, right? This one is something we're dealing with. After substitution and simplification, we came from here to all the way here. Yeah, yeah, we are here. Yeah, final simplified formula here. This one's done and this one's done. Now you just need to substitute. Okay, here is original formula. This is original formula. So in this place you can place this. Wait, not this. Yeah, so we got the standard, what's that? Carl Pearson's formula, and then we also proved that fundamental theorem of statistics, as you have told, right? The expectance and covariance related formula, and then we need to actually put all the things together into the step deviation method of correlation and get the formula. So, can you walk me through that once again, please? Okay. ChatGPT gave us a hand in the correct time. Let me just copy it. Let me close ChatGPT. Let me open it again. And let me paste it. Okay, we already proved it. Okay. So the computational form is Wait, what? sigma x square minus n x bar whole square. Okay, from where did this thing come? Oh God, I think I saw the proof for this one as well. Yeah, this one, right? Yeah, we messed it up. Linear transformation invariant. Okay, the name itself says a lot. So, where did we mess this up? Xy minus and x bar y bar, that makes sense. And what about this one, right? Wait, we already know some rules of summation. Why don't we use them out? Sigma x minus x bar whole square. So that will be, let us use our classic identity a minus b whole square. It is x square plus x bar square minus 2x x bar. So that will be sigma x square plus sigma x bar square minus 2 sigma x bar. So what are the constants here? X is a variable, leave it as it is, and n x bar square minus 2 x bar summation of x. Is it? So from that, how did he get this? Okay. You might actually think me as asking dumb questions for passing these many times, but this is literally my first time of doing an actual proof for a mathematical formula. So, how did you come over through that sigma of x minus x bar whole square is equals to sigma of x square minus n x bar square? I kind of expanded it and I found out that x bar square and 2 are the constants. So I got them out of the summation, but I could not get the final form. Okay, we did that. We did that. X bar is a constant. It does not depend on I. Okay. 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 We did that too. Okay. Nice. We did that too. So sigma x square minus 2x bar sigma x. What? Okay, sigma x square is sigma x square minus 2x bar sigma x. Okay. Yeah, he just kind of rearranged the terms. Why am I confusing? Using mean definition. Okay, for x bar you need to use the mean definition. I mean for sigma x. Now to remove sigma x, right? So x bar is equals to sigma x by n. And now sigma x will be nx bar. It is as simple as that. So sigma x square. How do you get that sigma x square? Okay, you don't need to mess with this sigma x square. You just need this. Sigma x is an x bar. Is that it? Yeah, 2x. 2nx bar square. Okay. 2nx bar square. Okay, this is not power minus 2 by the way. Nice. We made it. The missing link was this substitution. Yes, it indeed is. How many minutes since it been we started this stream? 42 minutes, alright. So where are we now? We derived this thing from this thing. Okay, okay, okay. Invariance, okay. 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 Mm-hmm. Wow, OneNote's not responding now. And before it was ChatGPT. Is the data becoming too big in OneNote or something? It is frequently doing this. It is frequently not responding. I feel like the OneNote is becoming too big and it is not being interactive enough. Maybe PDFs and Export file, export entire notebook. File, export notebook. Nice. One package. Wow, I'm not sure this goes like this. So now I can delete this entire notebook, I see. That thing crashed out. Yeah, I guess this crashed out again. What happens if you export this as PDF? Okay. Did it crash again? Okay, now it came out. That's good. Nice, right? So now you can delete it. I feel like I can close this notebook. It's closed just like that. Okay. So to actually unpack it, I deleted it, right? Nice. Okay, we have it. I don't know what this one is. Okay, this is a prototype. I need to clean all of this mess up someday or the other. Anyways, let's proceed. Oh yeah, we have that page as well, right? Wait, wait. I did not delete it, right? I deleted it. So if you delete it here, no, they are different. No worries. Let's create a folder here. Let's clean this mess in the first place. You don't need this. No, you don't need this. Oh wait, no. Mm, let's go to stuff. Yeah, you don't need this one as well. Hey bro, you seem low. Don't worry about the views or shit. It will come from later. No, bro. Like I was just checking for comments. I can pop out the chart and all. The problem is I have been streaming for a very long time and the voice kind of became low. No, I don't care about views and thanks for the concern. Yeah, you don't need this. Yeah, you need this. Let's pull it to DBMS. No, you don't need this one too. Yes, that organization is enough. Yeah, I don't need this too. Yeah, that is enough. Now let's cut it over here and let's create a new folder. Notes and inside that let's paste it. So now my question is this. If you delete all of this here, will they be saved over there? Okay, OneNote's not responding again. Okay, I don't want to mess this notebook. Okay, it is impacting. Okay, I need to close this notebook first. And then I need to check if it is working. Yeah, it is not impacting. That is a good thing. So we have our notes backed up. And then let's proceed. Why is it not opening? Okay, I guess this needs a little break and all. Where did it save? Should I import all of that? All of that, that I have done before. We did nothing much, we just proved some results. Actually, it would be good if I had that previous notes and all, but I guess it's alright. Yeah, this one, right? Yeah, that is annoying, man. The clock sound. I need to use a new clock, maybe. P&S is probability and statistics, bro. If you are here. Okay, guess I need to type it and pin it. P&S is probability and statistics. But you can think of the clock as a reminder to you every second that there is not enough time for you. Maybe. Just maybe. I started from standard deviation. So in the place of x, you can write a plus hu, and in the place of y, you can write b plus kv. Okay. Okay, that's basically a times b whole square. Okay. Okay, guess I need a break now. It is high time that I need to take some break and bye people. We will meet after some time. Did we have any chats?